now we have a constant velocity buggy. It starts at 20 centimeters and moves forward at a speed of 5 centimeters per second. And we want to write down its equation of motion. So I've worked out practice exam number 1, so I'm going to be a little bit quicker with this one. We know that this is the velocity. We know that this is the y-intercept on the graph. If we're talking about a line, so this corresponds to the slope, this corresponds to the y-intercept because we're using the general equation x equals v naught t plus x naught. And just to review, if these are the axes, if this is the position axis and this is the time axis, then the object moves like this. And of course the slope is v naught, which is the velocity. And the y-intercept is that x naught position right there. So when we go ahead and write down the equation of motion, it's moving forwards, so that means this is plus 5 centimeters per second. We write down its equation of motion as x equals 5 times t plus 20. And we want to ask, where will the buggy be at the end of 8 seconds? That's going to be 5. Oops. So x equals 5 times 8, because that's what we put in for t, plus 20, which gives us that the buggy is at the 60 centimeter mark. Now let's go ahead and plot the position versus time, knowing that the starting position is 20 centimeters. So one thing, I can just go here. So I'm going to actually count by increments of 5 just to make my life a little bit easier. So here I am at the 10 centimeter mark, the 20 centimeter mark, the 30, 40, 50, and 60 centimeter mark. And so we can count here as 2, 4, 6, 8, and 10 seconds. That's good enough. Now we start at 20 and we move at a velocity of 5 centimeters a second. So we're going to start here at this, and then after 1 second we'll move up 5, 2 seconds we'll move up another 5. Continuing on this trend, what we see is an object that moves like this. And the other thing we realize is that, in fact, after 8 seconds, it is exactly at the 60 centimeter mark, thus confirming what we got with our equation. So again, we are at 8 and 60. So that is problem number 2 on practice exam 2.